Hi, welcome to the demonstration of PyVulAudit, a tool for analyzing vulnerability reachability in the PyPI ecosystem. Today, software development heavily relies on third-party packages. Sonatype report points out that requests for Python package are expected to hit 530 billion downloads by the end of last year. The number of vulnerabilities is also growing rapidly, reaching up to 40,000 by the end of last year. This poses a severe challenge to the software supply chain security. It's important to understand how vulnerabilities spread through the ecosystem. However, current tools are pretty basic. They almost operate at the package level. They generate reports by flagging any dependency with known vulnerabilities, which creates a lot of false positive reports for developers and security teams. To bridge this gap, we are introducing PyVulAudit, an automatic tool for fine-grained vulnerability reachability analysis tailored for the PyPI ecosystem, one of the most active package repositories. Let me show you the workflow of PyVulAudit. PyVulAudit consists of three core modules: vulnerability collector, patch parser, and reachability checker. In the first step, the vulnerability collector collects information from OSV database, which agrees adversaries from many sources, such as NVD, GitHub adversary, and Python package adversary. It cleans up the data, removes duplicates, and finds the potential fixing commits for each vulnerability. In the second step, the patch parser performs the scope-aware patch analysis to identify vulnerable functions. PyVulAudit examines three distinct scopes: function scope, class scope, and module scope. It uses AST to extract code elements and collect the modified elements from fixing commits. For function scope modification, PyVulAudit directly marks the modified functions as vulnerable. Beyond that, PyVulAudit also addresses module and class scope modifications. By identifying the functions that reference the modified code elements, such as code attributes and module variables, it marks these functions as vulnerable as well. In the last step, the reachability checker performs both package level and function level analysis. For each vulnerable package, it first retrieves dependents by using OSI API, then it installs them in an isolated Docker environment and constructs an inter-package call graph. Finally, it performed function level analysis to extract vulnerable invocations in the downstream packages.
Now, let me show you how to use PyVulAudit. PyVulAudit has been open sourced and is available on GitHub here, with a detailed README that teaches you how to use it. You can clone the repository, and after setting up the environment, you can use it locally.
We use CVE 2020-1357757 to demonstrate the usage of PyVulAudit. First, we collect vulnerability information using this command. You can see the overall result in the terminal. Next, we use this command to conduct patch analysis to identify vulnerable functions. You can see there are 4 steps in total. In the first step, PyVulAudit process and verify the potential fixing commits. Then it analyzes the scope of changes. Finally, it uses different strategy to identify vulnerable functions. For this vulnerability, PyVulAudit extracts 4 functions from the 2 fixing commits. To conduct the reachability check, we first need to collect downstream packages for this vulnerability. Let's execute this command. It will first collect dependents and then create a snapshot for each vulnerable package to store the dependents. For this vulnerability, PyVulAudit identified 59 downstream packages in total. Next, we install these packages and construct inter-package call graphs. This step needs a long time to finish. After it finishes, we execute this command to perform the function level check. From the results, we can see that for this vulnerability, 4 downstream packages are reachable to vulnerable functions in the 2 vulnerable package versions.
That's how PyVulAudit works and how to use it. Thanks for watching the demonstration.